All right, here we go. So a particle moves along the x-axis with velocity as shown in the graph above. So this is velocity, which means this is the derivative. We're starting at time 0. Notice this, its position x of t at time 0 is 7. That's important for us to use here in a little bit. At time equals 0, is the particle moving left or right? Justify your answer. It's moving to the left because the velocity is negative. Okay, so we're going to write left because our velocity via t is less than 0, which is negative. When is the particle at rest? Again, this is the velocity. So when does a particle come at rest? When velocity is what?
0.
So it's at rest at 2, 7, 15, and 19. So t equals 2, 7, 15, and 19. When does the particle change direction when we have a turn?
The same time.
So at, well, not necessarily. At 2, at 5, at
14. Would it be 14? Or would it be...
okay, I'm sorry. I said that completely wrong. I was thinking concavity. Can I change it again? So when our velocity is negative, moving to the left. When velocity is positive, moving to the right. So how about we get it right? When do we change direction? At 7. Why not 2? Went negative, stopped, went left, stop, left. So at 7, 15, and 19. Okay. When is the particle speed the greatest?
22.
Well,
Wouldn't it be...
the absolute values. So the absolute values, guys. Absolute values of velocity. So here, what's my velocity? -3. So the absolute value of -3 is 3. Absolute value here is 3. What's your velocity here everywhere? 3. And at here's 3. So you're going to tell me, so when is the speed? You're going to tell me time equals 5. You're going to tell me that time equals from 9 to 14 and at 16 and 22. Did I say that right?
Yeah.
All right. What is the acceleration of the particle at t equals 1? So right here's t equals 1. Isn't acceleration the derivative of velocity, which is the slope right here? So what's the slope, guys? 1. So what is the acceleration at time equals 1? 1. And it would let's see, does it say as units per second squared? Units per second squared? When is the acceleration 0? From 9 to 14, because isn't the derivative here 0 from 9 to 14? What is the total distance traveled from 0 to 15? Total distance traveled would be simply the antiderivative from 0 to 15, but we're going to think of it in terms of absolute value. Because even though we're traveling left, right, the total distance is distance. You follow me on that? Okay, so let's see here. You got to help me find the area of these of this triangle. Let's see, it's a 2 by 2. So 2 times 2 is 4. Half of 4 is 2. So we're going to go 2 plus the area of this triangle will be, let's see, the base is 1, 2, 3, 4, 5 by 1, 2, 3. Half of 15 is 7.5. We'll say 7.5. Plus, your choice. You could do a trapezoid, or you could go triangle plus rectangle plus triangle. You follow me? It's going to give me the same thing. Everybody find the area of all from 7 to 15. Everybody find that area for me. I would break it up into triangle, rectangle, triangle real quick instead of doing half the height times the sum of the two bases. I did 2 plus 7.5 plus, what was this, 3? Plus, that rectangle was 15 plus 1.5, and that gives me a total of, is that what, 29 units? Now that was absolute value. What is the particle's position at t equals 15? Now, I want you all to start about this. I told you at the beginning. What's the position at t equals 0? 7. So everybody put 7. And then you're going to do what?
Subtract.
You're going to subtract. Look up here. Look up here. Subtract, subtract, then add. Because position's different than total distance traveled. So you're going to go 7 minus 2 minus 7.5 plus that 3 plus 15 plus 1.5. What's that give you?
17.
Yes. When does the particle reach its maximum position? So when? So I start at position 7, then I go backwards, backwards, forward, backwards, forward. Where do I reach my maximum position at? Time equals what? What do you think?
Should be 22, shouldn't it?
Well, here's the deal. You got it. This I'm going to say 15 off of just looking at it. The only reason why I'm going off that is, JT, I think this triangle is a little bit bigger than this triangle. Look, 1, 2, 3, 4 by 3, or this is 1, 2, 3 by 3. So you see how this is a bigger negative than this positive? So time equals 15. Good AP question right there. Because this takes in the most positive at right there. I never get bigger positive value than right there. What is the particle's minimum position?
7.
Yeah, 7. Because look, you start at 7 and you go minus, minus, and from there on I'm going to be adding, so at t equals 7.